If you have an interview coming up and you want to revise 10 most important machine learning algorithms real quick, you will not find a better video than this. Let's go ahead and do the revision of 10 most frequent used ML algorithms. These are the 10 algorithms I am going to explain you how they work and what are their pros and cons. Okay. And as you can see, first 5 algorithms is in one color, next 3 is in a different color, and last 2 is in a different color. There is a reason for that, guys. I will tell you in a moment. But before that, let's try to answer 2 basic questions. Okay. Let's try to answer what is machine learning and what are algorithms. Okay. So I'll start with a non-bookish definition and I will give you one simple example. Suppose you want to travel from Bangalore to Hyderabad. Okay, where you want to go? You want to go from Bangalore to Hyderabad. For this, you can either take a train or you can either take a flight or you can take a bus as well, or maybe you can drive your own car as well. Okay, so 2 things we have to understand here, guys. What is the task? Okay, and what is the approach? Fine. So the task in hand is we have to go from Bangalore to Hyderabad. Okay. And the approach is all these 3 options that I told you just now. Now related to the world of machine learning. In machine learning, the task can be different kinds of task. Okay. For example, it can be a regression task. Okay. Or it can be a classification task. Okay. Or it can be a unsupervised learning problem. I will just write unsupervised. Okay. So in approach section, we can have different approaches based on if we are solving a regression problem or we are solving a classification or we are solving a particular case of unsupervised learning. Okay. In regression also, we can take many approaches. For example, in regression, there is not only one approach. In regression, I can take approach 1, approach 2, approach 3, approach 4, approach 5. In classification, I can take this approach, this approach, this approach. In unsupervised also, I can take multiple approaches. So that is why this color coding is there. The first 5 algorithms that you see here will solve, I will explain you for regression use case. Okay, so there we will take a regression use case and try to understand how to solve that using these 5 algorithms. Okay, the next 3 that you see, I am going to explain you with a classification use case. So these approaches are for classification problem. Okay, and last 2 I am going to explain you for a unsupervised learning problem, how that will be, these algorithms will be used to solve a unsupervised learning problem. Okay, so let's go ahead, guys, and try to understand with a simple input data. I have taken a sample input data here, and let's, without any delay, start on the first algorithm known as linear regression. So machine learning is all about learning pattern from the data using algorithms. Okay, so if we are using an algorithm known as linear regression, then what will happen? Let's try to understand that. So first algorithm of our list, linear regression. Okay. Now suppose this is the employee data of an organization. You have a age column, you have a salary column. Fine. So 22 years person earns 23,000 and so on and so forth. Suppose we using the linear regression approach to solve this regression problem. Now, as I told you, first 5 problems will be regression problems. First 5 algorithms we will understand using regression problem. Okay. Come here, this is your data. So what linear regression will do is, it will just take this data and it will see how the data is plotted on a XY plane like this. For example, on one axis, we can take salary, okay, on Y axis, and on X axis, we can take age, okay. And I'm just roughly pointing these points, okay. First point, 22 and 23,000. Maybe it can come somewhere here. On X-axis, if you put age, on Y-axis salary, I'm just putting here. Second data point can come somewhere here, let's say 41 and 80,000 data points. And third data point, 58 and 150K. This data point can come maybe somewhere here, I can say. Okay. So what linear regression will do is, it will try to plot a line. Okay. Ideally, what the assumption is, all these points should fall on same line. a line like this can be plotted or a line like this can be plotted. But the assumption here is, ideally, in an ideal world, all these points will fall in the same line, but it will never happen in the real world. So what linear regression will do is, it will try to fit something known as a best fit line. Okay, so this is a best fit line. Let's assume that. How this best fit line is computed? It will try to minimize the distance from all these points together. So distance from this point is this, distance from this point is this, parallel to y-axis, distance from this point is this. Okay, so you can call this E1, you can call this E2, you can call this E3. Okay, so what linear regression will do is, it will try to minimize E1 square plus E2 square plus E3 square. For whichever line it finds the minimum E1 square, E2 square, E3 square, it will call that line as the model. Okay, it will call that line as the model. Now, as you know from your normal understanding of mathematics, this straight line will have an equation in the form of, mostly simplest we can write y is equal to mx plus c, right? In our case, I can say salary is equal to m times age, m times of age, this is multiplication, plus c can be an intercept. Let's give some number here, some random number I will give, let's say 2000. Okay, so imagine this line, which is the model for linear regression, has this formula. Okay, now the next question comes, tomorrow when the pattern has been learned and a new age comes, let's say age is 50. So what will be the salary for that person? So very simple, the model will come here and put the numbers here. For example, if for M, we can put any number, let's say 0.2, then age will be 50, and then salary will be, intercept will be 2000. Whatever this calculation comes, that will be the prediction of the salary for this 50. Okay, very simple mathematical model. The assumption is there is a linear relation between independent variable and target variable. Okay, that's the assumption. So what it will do, it will try to plot a line, what it will call as a best fit line, wherever it finds this value as minimum. Once the best fit line comes, then how the prediction happens, like this. Okay, obviously there will be pros and cons of all the algorithms, all the models. So what is the pros and cons of linear regression? The pluses or pros for this model will be, it's a simple to understand model, it's a mathematical model, you can explain to someone. But the cons will be, it's not necessary that your data will always be this simple, that can be fit in a line, right? Or close to a line. So it's a simple model, hence a lot of real world problems it may be difficult to solve with simple linear regression. There can be a varieties in linear regression that I have created videos, you can watch those videos, but simply linear regression works like this. Okay, this is one first approach. First approach means first algorithm. Now let's go ahead and try to see how decision tree will approach the same problem. Okay, how decision tree will approach the same problem. So if you give this same data, okay, if you give the same data to decision tree and you ask, hey, learn pattern from this data, what decision tree will do is, it will just try to break the data. How it will break the data is, it will create a rule like this. Okay, so I can write a rule here. For example, I can say age less than equals to 30. This is a rule. Okay, so some records will satisfy this rule. Okay, some records will satisfy and some records will not satisfy. This way data will break. Okay, if you come here, age less than 30, how many records? Only one record. Age more than 30, 2 records. So how many records will come this side? Only one record will come. Okay, so let's say that record is, I should not write the wrong numbers, 22, 23K, 41, 80K. So I will write here 22 and 23K. And here I will write 41 and 80K. Okay, and there is one more record. Let me take the numbers, 58 and 150K. 58 and 150K. Understand this carefully, guys, because for next algorithms, this is the base. Okay. So decision tree will split your data like this. So you had total how many records? In the beginning, 3 records. Here, how many records you are having? 1 record. Here, how many records you are having? 2 records. Okay. So this is first level of split. Now decision tree can split it one more time. Okay. So tree can make here there are limited number of records, but imagine if there are more records, there can be one more split here saying, another filter is maybe less than 40 or something like this. Okay, but I will not take that now. That will make the tree complex. Okay, so this is your model. Breaking your data based on some conditions is nothing but your model. So somebody asks you what is a model in decision tree? This is your model. Now the important question is, suppose tomorrow somebody comes and asks, for a person with age 50, what is your prediction? For a person with age 50, what is your prediction? Very, very important concept to understand, guys. Decision tree will come and check what is this for age 50. Okay, so age 50 will come in which category? Will come in this line. Okay, in this line, how many records are there? 2 records. So decision tree will go ahead and take the average of these two salaries. So for age 50, your prediction will be, what will be the prediction, guys? For age 50, prediction will be 80K plus 150K divided by 2. Okay, this is how decision tree will be making the prediction. Suppose you ask to decision tree, hey, what will be the salary of a person with age 21? So it will not go to right hand side. It will go to left hand side because this is the tree branch in which it should go. It will directly say 23K in this case because there is only one record. Suppose there are 2 records, it will take the average. Okay. So you see how these two approaches are different for solving same regression problem. Here a mathematical line will be fit, and here a decision tree, data will be broken into multiple pieces and prediction will be made. Okay, remember guys, decision tree is base for many other advanced algorithms, and our third algorithm in the list is something known as a random forest. Okay, random forest. What random forest will do is it will say decision tree, okay, you have done a good job, but there is a chances of overfitting of the data. So we did not discuss pros and cons of this. Pros is it's a simple model, you don't need to do a lot of mathematics, etc. And cons is there is a chances of overfitting because if there is a little change in the data, your model may change totally. That's a risk here in decision tree. So overfitting. So random forest will come and say, hey, you are taking a right approach, but there is a chances of overfitting. So why don't you fit multiple trees? So what random forest will do is it will come and create multiple trees. This is your tree 1. Okay, like the way we saw decision tree. This is your, for example, tree 1. Okay, this is your, for example, tree 2. Okay, and similarly, there can be n number of trees. Okay, similarly, there can be n number of trees. So we will call this as T1. We will call this as T2, and there can be 500 trees, for example. So what random forest will do is it will say to decision tree, hey, if you are fitting one tree, there is a chance of result being biased, or there is a chance of overfitting, or there is a chance of model not being stable. But what I will do is I will fit 500 trees. Okay, and how I will make the prediction is very important to understand here, guys. Prediction of random forest will be average of all these prediction. For example, if we are trying to predict for the age 50, right? For the age 50, what will be the salary if we are trying to predict? Okay, then in random forest, it will take prediction from tree 1 plus prediction from tree 2 plus prediction from tree 500. Okay, it will take all the predictions and it will take an average of that. What is the thing that we are trying to achieve here? Suppose in one decision tree, your tree is overfitting or not performing well or is biased. Okay, so what may happen in decision tree, since you are taking a feedback from 500 different trees, so that overfitting problem or model instability problem may not be there. Okay, so this is how random forest is different from decision tree. Remember, all these individual trees will not be using all the data. For example, suppose in your data, there is 1000 rows and 10 columns. Okay, just an example I'm giving. So all these trees will not use necessarily all the records. It may be possible that tree 1 is using 100 records and 3 columns randomly selected. T2 is using tree 2, 100 records and 3 columns randomly selected. Okay, and that is the advantage of this random forest, that all these trees may learn a different kind of pattern, and when you take a aggregated result, then you will have all the flavors. Okay, this kind of learning that I just explained you is known as ensemble learning. Okay, remember guys, at Unfold Data Science you will find a big playlist explaining all the algorithms of ensemble learning in detail. I will paste the link in the description. You must check if you have any confusion on how ensemble learning works. Okay, but there is more to ensemble learning. What happened just now in random forest is known as parallel way of learning. Okay, parallel way of learning. Parallel way of learning. Why parallel way of learning, guys? Because here tree 1 and tree 2 and tree 3 are independent of each other. When you call a random forest model, tree 1 can start building by taking a subsample of the data. Tree 2 can start building by taking a subsample of the data. They are not dependent on each other. Okay. So all these things can happen parallelly. Hence we call it a parallel learning. Now, the question is there another way of learning in ensemble? Yes. There comes our next algorithm known as AdaBoost. Okay. AdaBoost, standing for adaptive boosting. So what AdaBoost will do is, let me write the data here. Let me write the data one more time, and I may be writing some different numbers. So that's not important. Just understanding the concept is important. Okay. So 42, I will write 50,000, and let's say 58, I will write 150,000. Just as an example, this is your input data. So boosting is another technique. Boosting is another technique of ensemble category. Okay. In boosting, especially AdaBoost, what will happen is it will assign a weight to all your observations. Okay. Suppose this is your original data for training, salary being your target column. So initial weights, okay. And what the initial weights will be, it will be the same weight for all your records. For example, there are 3 records. So 1 by 3 I'm saying, 1 by 3 I'm saying, 1 by 3 I'm saying. So all the rows are equally important. Okay, try to understand the concept, guys. In AdaBoost, in the beginning, first iteration, all the rows are equally important. Okay, but how AdaBoost works is, in the name only there is adaptive. It adapts to the mistakes of the previous model. Now, why I'm saying a previous model and next model is, one thing you have to always remember, AdaBoost is a sequential learning process. You remember how I just now told random forest is a parallel learning process. So in random forest, tree 1 and tree 2 are independent of each other. Okay, it will take a subsample and create, it will take a subsample and create, nothing to do with each other. But in AdaBoost or other boosting techniques, it's a sequential model. So there will be a multiple models in this. So there will be multiple models fitted to the data. I will tell you in a moment what these models will be. Model 1, model 2, model 3, model 4, and so on and so forth. How many ever model comes, but it will not happen parallelly. Okay, it will happen in sequence. Now the important thing to understand is how this sequence will be generated. Okay. So what will happen is, this model 1 you can think of as a base model. This model 1 you can think of as a base model. And remember, in AdaBoost, your decision trees will look like stumps. Stumps means there will be a tree like this, and there will be another tree like this. So the depth of the tree will not be beyond one level. Okay. So this is called stumps in the language of machine learning. So multiple stumps will be created. Now suppose your model 1 is this first stump. What is your model 1, guys? This first stump. Okay. Model 1 comes and makes some prediction about the salary. Model 1 comes and makes some predictions about the salary. Okay. So what we will have is another column called as salary underscore prediction. And where from this prediction comes? This prediction comes from model 1, the first model. Okay. So obviously there will be some mistakes. So 22,000 may be said as 21,900, and 50 and 150 can be said as, 50 can be said as, let's say 52,000. Okay. And 150 can be said as, let's say 200,000, based on this first model, first decision tree that it is creating, which I am calling a stump. So there will be some differences between actual and predicted. And from this, there will be a residual coming. Residual means errors, right? Residual means errors. Okay, so what will be the errors? 21,900 minus 22,000, right? So it will be, for example, I can say 100 actual minus predicted. It is minus 2,000 and it is minus 50,000 because we have put. Okay, so this is the errors. These are the actual values and the first model, what it predicts, right? Those are the errors from the first model. Okay, 22,000 minus 21,900 is 100 and so on and so forth. Now, these are the initial weights. Okay, so what will happen in the next model when the M2 is fitted, right? These initial weights will be changed and more preference will be given to the observations where these residuals are more. Okay, I'm repeating one more time, guys. M1 will predict this and then residuals or errors will come. When the M2 is trained, right, then the weights will not be same for all these three records. Rather, weight will be increased for this because you are getting more errors here, and weight will be decreased for this because you are getting less error here. Okay, and so on and so forth. M2 will come, compute, create the residual, then again weights will be adjusted. M3 will come, predict, residual will be calculated, weights will be adjusted, and finally what you will get is a combination of what will be your final model. Your final model will be a combination of base model, I'm calling it the first model, okay, plus M1 plus M2 plus M3 plus so on and so forth. Remember, this is not a mathematical equation. This is just an indicative equation I'm giving you. Okay, if you want to understand more mathematics behind it, please go ahead and click on the link I'm giving you in the description. Okay, and all these things will not have equal say in the final output. Their say also will be different in the final output. For example, in random forest you saw all the models have equal say in the final output. We are dividing by 500. Okay, but here all these models will not have equal say, they will have unequal say. Okay, let's move ahead to another. What is the pros and cons for this model? Again, this model will give you may give you a better result than most of the models because it is adapting to the changes. But if you have a larger data set, it may need more resources to train. And also it is a one kind of black box model. Some kind of black box model means you don't have much explanation of what is going on inside apart from some hyperparameters. Okay, let's move ahead to the last algorithm in regression category known as gradient boost. Okay, what is the last algorithm in regression category? Gradient boost. Remember guys, all these algorithms that I'm explaining you, I have not taken anything that is used less. All are used more only. Okay, so I will take a simple data, age, salary, age 21, salary let's say 20k, age 40, salary is let's say 42k, age 58, salary is let's say 60k. This is your input data and you want to run a gradient boost on this. What will happen is, understand guys, this is again a sequential learning, not a parallel learning. Okay, so there will be a base prediction for all these data. Base prediction. Okay, base prediction. What is the base prediction, guys? Base prediction is nothing but it's a kind of dumb model. It will assume that for all these guys, it will be an average of, you know, all these three records. So what is the average of this? 80 plus 42. 80 plus 42 divided by 3, right? So 2112, right? Let's assume for simplicity, this is 36K. Okay, so the base prediction will be put here 36K, 36K, 36K. Once the base prediction comes, then there will be a residual computed. Okay, residual will be the difference between actual and predicted values, whatever these numbers are. Fine. Now comes the interesting part, how gradient boost is different from ADA boost or other algorithms. So what gradient boost will do is, it will try to fit a model on this residual. Okay, it will try to fit a model on this residual and try to minimize these residuals. So that will be called as a base model. Okay, and then there will be next model. You can call it residual model 1. Okay, and then there will be a next model. You can call it residual model 2 and so on and so forth. Okay, so what will happen is residuals will be computed and then whatever the residual comes, based on that base prediction will be updated. So for example, let's say your residual here is how much? 20 minus 36 minus 16 is your residual, right? So these will act as an independent column and this residual will act as a target column. And then let's say in the prediction, this minus 16 is comes as, let's say, minus 10. So what will happen is this base prediction will get updated by this. This base prediction will get updated. Again, it's a complicated model. If you want to understand more details, there are links in the description. Please click on that. It will be very clear to you. Okay. So what will happen? Base model plus residual model 1 plus residual model 2, so on and so forth. And there will be some parameters which will assign weight to all these models. So as I say, all these models will not have a equal vote in the final output. There will be a different votes in this. Fine. So this is about gradient boost, one of the famous algorithm for winning Kaggle competitions and most of the things. So gradient boost, and there is another variant of gradient boost known as XGB, extreme gradient boost. Please go ahead and read about this algorithm, guys. I'm not covering because there is a slight difference between gradient boost and XGB. You can read about that as well. Fine. Let's move ahead to the second category of algorithms known as classification algorithms. So in classification algorithms, the first algorithm that I'm going to cover is logistic regression. Now, very, very important, guys, please pay attention here and try to understand how logistic regression is going to work for any given scenario. It's a mathematical model. Hence, it is important for you to understand. Okay. Suppose this is an employee data and you have 21, 22K, whether the employee leaves the organization or does not leave the organization. Just I'm saying 10. Okay. And then 40-year guy makes, let's say 42K, leaves 0, no. 58-year guy makes, let's say 60K, just for example, leaves no 1. So this is a classification problem where we are trying to predict whether an employee will leave the organization or does not leave the organization. The last column that you see is your target column. The last column that you see is your target column. This type of problem is called a classification problem because what the objective of this model is, tomorrow I give you age of the employee, for example 31, salary of the employee, for example 34K, and I ask to the model, hey, will the guy leave or not leave the organization? Okay, so this is a classification problem. How logistic regression will take this problem is we have to understand some mathematical concepts here. So if you see here, the target column is 1, 0 only. So that is either 1 or 0, 1 or 0. Okay, so which means that y, which is our target, can be, understand this is very important concept, guys, can be either 0 or 1. It cannot be anything else. Your target cannot be anything else apart from 0 or 1. But your age and salary can take any real number. X can be any value between minus infinity to plus infinity, right? So x can be any value between minus infinity to plus infinity. Y can be only 0 or 1. Okay. So what we have to understand here is we have to somehow create a relation that will enable us to predict y given x. Okay. The problem here is on the left hand side, we have minus infinity to plus infinity range, that is x range. Okay. So I will write here x. X means independent features. On the right hand side, your values can be only 0 to 1, 0 or 1, not 0 to 1. Okay. So what we do is we do not directly predict y, rather we predict something else. What is that something else that we predict? So in place of predicting y, we predict probabilities. Okay. Probabilities of an observation falling in y. Probabilities. LITIES. Okay. So what we will do is we will predict probabilities, then the range will be 0 to 1. As you know, probability can take the range between 0 to 1. Okay. Now this range is also not what we are looking for, minus infinity to plus infinity. So what we will do is we will do one more transformation and we will make this as a odds. So what is the range of odds? 0 to infinity. Okay, but still we are not minus infinity to plus infinity range. So what we will do is we will take log of odds. Okay, log of odds. Okay, and then the range will become minus infinity to plus infinity. How your equation will look like here is when you say log of odds, right? So on the right hand side, it will be log of p by 1 minus p. Okay, on the left hand side, you will have beta naught plus beta 1 x1 plus so on and so forth. Okay, this equation that you see in front of you now is called the base equation for the logistic regression. Now, one important concept to understand here, guys, this is a logit function. Okay, and inverse of logit function is sigmoid function. Okay, suppose you take the inverse of this or sigmoid of this. So what will happen is if you apply sigmoid both sides. So if you don't know what is sigmoid function, then sigmoid function fx looks like this: 1 by 1 plus e to the power minus x. This is your sigmoid function. On xy plane, how it will look like is this. Suppose this is your 0, this is your 1, and this is your 0.5. Okay, so sigmoid will look like this. So it will always be between 0 to 1. Okay, so your logistic regression, this equation will be changed in the form of sigmoid function. So your fx or p, okay, p will look like, if you take sigmoid on both sides, right, then on the right hand side you will just have p, and here you will have 1 by 1 plus e to the power minus beta 0 plus beta 1 x1. Okay, remember guys, this equation is equation 1 and this equation is equation 2. Both the equations are same. The difference is this is a logit equation and this is a sigmoid equation. Okay, now take it, if you take a inverse of logit, that is nothing but sigmoid. Okay, understand this carefully. And now this equation from our example, how it can be written is 1 by 1 plus e to the power minus beta 0 plus beta 1 into age, okay, plus beta 2 into salary. This is nothing but your logistic regression equation. Okay, and as you know, as I told you, this is a sigmoid function. So the output of what you see here, output of this will always be between 0 to 1, which means you can get a probability, and then you can say that based on this probability, I can say whether the employee leaves or does not leave. Okay, logistic regression is again a very important and not easy to understand concept. Okay, so as you can see, we are modeling a categorical variable against real numbers, hence we need to do certain transformations. These are the transformations that we need to do, and how it relates to the probability I just explained you now. Okay, pros and cons, mathematical model, not very difficult to understand. Cons, it again assumes a lot of things about the data which may or may not be correct, hence it may not give a great result all the time. Okay, but very famous and very important algorithm to understand. Next algorithm in the category, in the classification category, one simple one I want to cover here, that is known as KNearest Neighbor. Okay, it's a pretty simple algorithm. Suppose in the same data, on this data, you want to build a KNN algorithm. Okay, so since I have data here, so I will explain here only. So what can happen is it will plot a XY plane like this. Okay, and it's a 3-dimensional data, so you can have one more axis for salary, or you can have 2 axes only, because from 2 axes we can predict. Okay, so let's come here age, and let's say here salary. Okay, out of these 3 employees, let's say one employee is 21, 22 employees falls here, and second employee 40 falls here, and 58 falls somewhere here. Okay, so what KNearest Neighbor will do is it will try to allocate neighbors to all these individual observations. For example, this is your observation 1, this is your observation 2, and this is your observation 3. Okay, so 1 does not has any neighbors, but 2 is the neighbor of 3 and 3 is the neighbor of 2. Okay, so tomorrow some prediction comes for, let's say, age 50. Again, I will take 50 example. So what it will do is it will try to see, and I will take salary also, because in this case salary is also there. So salary is, let's say, 61K. Okay, so what it will do is it will try to see where can I fit this 50 age person and salary 61K. Maybe who are the nearest neighbor to that guy. So the nearest neighbor to that guy may be this guy and this guy. Suppose that new guy comes somewhere here. Okay, so who are the neighbors for this? This is the first neighbor, this is the second neighbor. Okay, so it will simply go ahead and take the mode of results. For example, these two guys are the second neighbors, right? I mean two neighbors of that. So it will take 0 and 1, which is maximum. So in this case, there is no mode of the data, but obviously if you take a larger data, there will be modes of the data. Okay. So whichever mode, for example, suppose there are 30 records, out of that 20 is 1 and 10 is 0. So the prediction for this guy will be whatever is maximum or whatever is mode. So if the mode is 1 or 0, whatever it is, that will be the prediction for KNN. Okay. So as I told you, KNN is a pretty simple algorithm. It will just plot your data, try to find the nearest neighbors, and then when a new observation comes, you give how many neighbors you want for that record, and it will create on based on that. Okay. So KNN is a simple to understand algorithm, nothing complex in that. So I covered quickly in that slide itself. Okay. Now let's try to understand another classification technique known as support vector machines or SVMs. So what SVMs will do is it will plot your data in whatever axis you have. Suppose age is one axis and salary is one axis. Okay. And your data points, I will take little more data points. Okay. Your data points look like this. So these are some data points and these are some more data points. Okay. So what SVM will do is it will try to create something known as a decision boundary. Okay. How this decision boundary is different from linear regression decision boundary is in linear regression, there is a pure mathematical equation involved. Here, there is a concept of something known as a hyperplane. Okay. For example, if I draw a line between this, right? So all these guys, black guys, you can think leaves or target column is 1. All these guys you can think does not leave or target column is 0, does not leave. Okay. Suppose your data is like this. So what will happen is your SVM will plot. This is called, in the language of SVM, this is called a decision boundary. Okay. Decision boundary. So in this case, your data looks pretty simple, pretty separated. Hence the decision boundary can be as simple as a line. Okay. But in most of the scenarios, real world scenarios, decision boundary cannot be as simple as this. Okay. So there will be some black dots here. There will be some black circles here. Okay. And there can be some this cross, blue cross this side, right? So in this case, decision boundary is not doing justice. So decision boundary need to change. And that is where the concept of hyperplanes and kernels, two very important concept in SVM, guys. If you want to explore more on SVM, hyperplanes, okay, and kernels. So when your data become complex, then simple decision boundaries cannot predict it well. Okay. So you need to have a complex decision boundary, and that is where hyperplane and kernels concept come. But just to give you an idea of how SVM works, it will create a decision boundary, and tomorrow any prediction, any new result come. For example, somebody asks, what is the for a person with age 50 and salary is 60K, whether the person will leave or not leave. So this SVM model will see on which side of decision boundary this guy is falling. If this guy falls on this side of decision boundary, it says do not leave. If this guy falls on this side of decision boundary, it says leaves. Okay, so in SVM, remember concept of decision boundaries, hyperplanes, kernels, and kernel tricks. Okay, so we have covered 3 things from the classification scenarios and 5 things from the regression scenarios. Let's go ahead and try to see some unsupervised learning problems. Okay. So what is the meaning of unsupervised learning? Till now we are having a target column, but in unsupervised learning, we may not have a target column. Okay. Suppose for the same employee data, we have age and salary, but somebody comes to you and tells you that, hey, can you tell me if there are different buckets of employees existing in my organization? Different buckets means some people with less age and more salary, some people with more age and less salary. So are there different buckets? Somebody can come and ask you. Okay. So how you will solve that problem is by using something known as clustering or segmentation. Okay. So suppose the task in hand is here, there are 3 records only, but there can be more records, right? In the real world scenario, what I'm interested in knowing is if there are natural clusters in my organization. So this is my organization data. On one axis, I have age, on other axis, I have salary. Okay. And I have multiple data points here, 3 data points only, but I'm plotting more data points just for demonstration. Okay. So there is nothing to predict, but employer is interested in knowing if there are buckets, means if few employees are closer to each other in terms of their characteristics. So for example, these employees are closer, you can call bucket 1. These employees are closer, you can call bucket 2 or segment 2. Okay. But how this will be implemented is in k-means clustering. So one technique for implementing bucketing is k-means clustering. Okay. There can be other techniques also for segmentation or bucketing. One technique is k-means clustering. In this technique, what will happen is the distance between the various employees will be computed. For example, this is your employee 1 and this is your employee 2. Okay. Suppose I ask you, how similar is employee 1 from employee 2? So there can be different similarity metric that you can compute. For example, Euclidean distance or Manhattan distance or cosine similarity, etc. I have detailed video on these things as well. I will link it in the description. But suppose I tell you a simple, how the distance, how how these two employees are similar or different. So you will say 21 minus 40 whole square plus 20k minus 42k whole square. So on all the dimensions, you are taking the distance between them, squaring it and under rooting it. This is called Euclidean distance between E1 and U2, whatever number you get it. Okay. So suppose E1 and E2 Euclidean distance is less and E1 and E3 Euclidean distance is more. So in that case, you say E1 and E2 are closer to each other. Okay. And in the similar way, you start finding the employees which are closer to each other, and then you call this as one bucket. Similarly, you call it another bucket. Okay. Remember, I have explained you in simple terms, but there is a very important concept in k-means known as centroid concept. Okay. So please go ahead and watch Unfold Data Science detailed video on k-means clustering. You will understand all the details of how centroid is defined and how this algorithm works at a mathematical level. Okay, I will link that video. Please ensure you watch that. So this is about k-means clustering. Now, last but not the least, guys, you might have seen in Amazon and Flipkart that there are different products that is recommended to you. For example, if you buy a laptop, then it will tell you, hey, go ahead and buy this laptop bag as well. So this is nothing but a recommendation. Okay. In the Netflix, if you watch, let's say one action movie, let's say if you watch Mission Impossible, then it will go and recommend you Jack Ryan series, maybe. Okay. So this is called a recommendation system that is running in background. Okay. So how this system works, one simple yet powerful technique for recommender system is known as collaborative filtering. Collaborative filtering. Okay. So what collaborative filtering does is it will take users, okay, users, and it will take items. Try to understand this simple concept, guys. It's pretty simple to understand. So users can be Aman, and users can be John, and users can be Doe. Okay. And in the items, we can have, let's say, Mission Impossible. In the items, we can have Jack Ryan. In the items, we can have any movie of James Bond series. In the items, we can have Spider-Man. Okay. In the items, we can have any comedy movies. For example, Home Alone, you can say. Okay. So Aman, which movie Aman watches or which movie Aman has watched? For example, Mission Impossible Aman has watched. Jack Ryan he has watched, but he has not watched, let's say, this movie, Zero, I will say. Okay. James Bond movie. And this movie he has not watched. Okay. Spider-Man movie. There is another guy, John, who has watched Mission Impossible, Jack Ryan, James Bond movie, and Spider-Man movie as well. There is another guy, Doe, who has not watched any of these movies, but has watched Home Alone, the comedy movie. Okay. So the which users are similar to which user will be computed based on one of the user similarity metric. So what are the user similarity metric? I told you cosine similarity. It can be different kind of distance metric. So as you can think from the common sense also here, Aman watches action movies, if you can see here, and John also watches action movies more. Okay. Aman has watched Mission Impossible and Jack Ryan, but Aman has not watched James Bond movie and Aman has not watched Spider-Man movie. So what will happen is, since Aman and John are similar to each other, So go ahead and watch the movies that John has watched but Aman has not watched. Because Aman and John both taste are similar, so go ahead and recommend what John has watched but Aman has not watched. So what will be the recommendation going to Aman? James Bond movie and Spider-Man movie. Okay. Now imagine this is a large metric of large users and large items. So it will be seen which users' tastes are similar to each other. Okay. And then the other user which has not watched that movie will be recommended the movies or series based on the similar users watching history. Okay. This is pretty simple but powerful technique known as collaborative filtering. So let's revise once, guys, what all we discussed. Long discussion, but very, very fruitful for you to revise few fundamental concepts. Linear regression, decision tree, random forest, data boost, gradient boost for regression we discussed. Classification, I explained you logistic regression, how SVM works and how KNN works. And I explained you two unsupervised technique, K-means and collaborative filtering. Now, not in too much detail I went because it's not possible to go in all the details of 10 algorithms in short time. But treat this as a refresher and please go ahead and click all the links of whichever algorithm you are more interested in learning. All the videos are there on Alford Data Science. Okay. I request you guys, please press the like button if you like this video and please press the subscribe button and the bell icon if you want me to create more videos like this. See you all in the next video, guys. Wherever you are, stay safe and take care.